This section is going to be dealing with 2.1 notes from College Algebra 13-14. Okay, and the three things that we're going to talk about will be XY coordinates and graph, we're going to talk about intercepts, and the third thing we're going to talk about is symmetry. Okay. Let's talk about an XY plane or graph. Okay. What does that look like and what does it entail? With an XY plane, you have an x-axis and you have a y-axis. This point here where they cross is referred to as the origin. And the origin has a specific address or ordered pair or point 0, 0. With the XY plane, we also have this upper right corner, which is referred to as quadrant 1. And notice we use the Roman numerals for 1. And in quadrant 1, our x values in the points will be positive and our y values in the points will also be positive. How the quadrants rotate is counterclockwise. So this means that the upper left corner will be referred to as quadrant 2. And in quadrant 2, the x values will be negative, but the y values will still be positive. Rotating now down to the lower left corner, this is referred to as quadrant 3. And in quadrant 3, our x values are negative and the y values for points in that region are also negative. Finally, rotating to the last quadrant here in the lower right, this is referred to as quadrant 4. And quadrant 4 has x values that are positive in that quadrant and y values that are negative. Okay. Now, what have we talked about? We've talked about ordered pairs, right? We've talked about this thing called ordered pairs, and ordered pairs is a fancy word for point. And when we're referring to a point, there are two parts to that. There is an x value in the point and a y value in the point. Notice the x is coming before the y, and x comes before y in the alphabet is how you can remember that. Now let's talk about intercepts. Okay. With intercepts, what does it look like? And we can look at that by looking at a graph to describe or identify them. So let's do that. Notice we're going to go ahead and try to show a graph here. Okay. With this point, notice it is crossing the y-axis, and so that means this is a y-intercept. Okay, and also, how do we describe that point? Well, we're not going anywhere in the x direction, so the x value is 0, and we're crossing the y-axis at 3. So that's how we would describe that address. Here's the second point that we want to identify. Notice it's crossing the x-axis, so this is referred to as an x-intercept. And if we were to describe where that point is located, we are crossing the x-axis, so the x value is -4, but we're not going anywhere in the y direction, so the y value in that point would be referred to as 0. Okay. So what have we actually discovered about x and y intercepts then? Well, let's see. X-intercepts look like the following then. Well, when we're trying to find x-intercepts, we're looking for the x value when the y values are 0 in a point. Okay, similarly, if we were looking for y-intercepts, we would be looking for the y value in a point when the x values are 0. Okay. So then what does that really mean then? Well, to find an x-intercept, what would we do? To find an x-intercept, we would substitute a 0 in for y and solve for x. Similarly, to find a y-intercept, what would we do? Well, we would substitute a 0 this time in for x and solve for y. The third thing we want to talk about is symmetry. And with symmetry, there are three things we would want to look at. Let's look at the first. If we took a look at this graph here, and we were talking about symmetry with respect to the x-axis or symmetry about the x-axis, what are we saying? We're saying that the x-axis is the mirror. And so if the x-axis is the mirror, then let's see, the green will represent what the symmetric graph would look like. Okay, so then what is that telling me? If it's symmetric about the x-axis, what do the points look like? Points would look like an xy and x, negative y. Notice the x's are not changing, but the y's are becoming the opposite. So even in this graph, if I finish the graph where I had two sides, then it would be symmetric. Okay. All right. Let's look at a second thing that refers to symmetry. Again, we're going to go with the same graph, and let's take a look at this time. This time, we're going to talk about symmetry about the y-axis, or symmetry with respect the the y-axis. We're talking about symmetric about the y-axis. Okay, well this time the y-axis is going to be the mirror, so let's take a look. I'm trying to get the graph to show right. It's not behaving. There we go. That's closer. Okay, so what do points look like if it is symmetric about the y-axis? Well, let's see. Points here look like this. Still have an x and a y, but this time it's the y's that stay the same, and it's the opposite for x. Okay. The last symmetry that we'd like to look at is the following. And again, we're still using the same graph, but this time we want to talk about symmetry about the origin. Okay, and what would symmetry about the origin look like? Well, let's take a look. Again, with the green, what would it look like? And again, I'm really trying to get the graph to look pretty darn right here. Okay, and so points here, if it's symmetric about the origin, still have the x and y, but this time both x and y for the other points that are symmetric are the opposite. Okay. Let's do two examples just to see how we might apply these two things. I'll refer to my first example as example A. And the two things that they want us to do in this example is find the intercepts and once we find the intercepts, then they want us to graph. So let's work through this. Okay. Alright, this is the equation that we're using. It is y equals to 6x squared minus 6. Okay. Well, if we're looking for intercepts, that means we're looking for both the x-intercepts and the y-intercepts. Notice I'm going to abbreviate this as int. And remember, we have a definition where if we're looking for an x-intercept, then we're looking for the x value when y is 0. And similarly, if we're looking for y-intercepts, again abbreviating here, we're looking for the y value when x's are equal to 0. So to find this x-intercept, then we're letting y equal to 0. And we've now got 6x squared minus 6 left on the right hand side. And we're going to factor. We're going to factor in order to solve for x. So the first thing I'm going to factor out is the 6. There is a 6 in both of these terms. And when I take the 6 out, I'm left with x squared minus 1. Well, x squared is created by a perfect square. 1 is also created by a perfect square. It is separated by a minus sign. So how does that factor? Well, still have the 6, don't throw it away. This is going to factor now into two parentheses. And x times x creates the x squared, and 1 times 1 creates the 1. And because this is negative, that means one of these will carry a positive and one will carry a negative. Okay. Alright, so now 6 equals 0. X plus 1 equals 0. And x minus 1 equals 0. Okay. Alright, well let's think about 6 equals to 0. Does that even make sense? No, 6 is never going to equal 0, so I'm not getting anything from that. Okay, if I solve this one for x, that will give me x equals to negative 1. And if I solve this one for x, this gives me x is equal to 1. But now how do I write those as points? As x-intercepts, this would be described as negative 1, 0, comma, and this one would be described as 1, comma, 0. Okay. Alright, we found the x-intercepts now. Let's find the y-intercepts. Okay, the same thing, same equation. This time we're looking for the y-intercepts in it. Again, how do we describe the y-intercept? We're looking for a y value when x is 0. And we're going back to our original problem that said y was equal to 6x squared minus 6. Well, this time we're substituting a 0 in for x. Let's do that. And when we do that, well, 0 squared is still 0. And 6 times 0 is still 0. So then our y value is equal to negative 6. So what is that as a point? As an intercept point, this is described as 0, negative 6. So what have we found our intercepts to be? Well, let's look at that again. We had two x-intercepts. Remember, they were described as negative 1, 0, comma, 1, 0, and we now have a y-intercept, comma, that's also referred to as 0, negative 6. Okay? But remember, the last thing that this problem wanted us to do was graph. So, what are we going to do? We're going to graph using the intercepts. Okay, we're going to graph using the intercepts. Okay, so again, the intercepts that we had were points that were described as negative 1, 0, (1, 0) and comma 0, negative 6. So let's try to put these on a graph now. Okay, so where are these points at? Let's plot them. Well, negative 1, 0 is right here. 1, 0 is right here. And 0, negative 6 is right here. And when we connect these points, there's our graph. Okay? Alright. Let's do one more example. Example B is going to have us do two things. It's going to have us find the intercepts and number 2, it's going to have us test for symmetry this time. Okay, and this is the equation that we're using. Y equals to x to the 4th minus 3x squared minus 54. Okay, once again, if we're looking for intercepts, we're going to be looking for an x-intercept, which is going to be described as finding an x value when y is 0. We're going to be looking for a y-intercept, which or y-intercepts, which we're looking for y values when x's are 0. Okay, with that in mind, 0 equals x to the 4th minus 3x squared minus 54. And we're probably going to use some prime factors to help us out. What prime factors of 54? What prime factors of 54 will, in this case, subtract to get us that negative 3 that's in the middle? Well, let's take a look. 2 is in 54 27 times. 3 is actually in 27 9 times, and 3 is in 9 3 times. So the prime factors that create 54 are these 4 factors. But we don't want all 4 factors. We don't want them representing as 4 factors. We want 2. So let's think how we could look at this. 2 times 2 oops, I'm sorry, let's try that again. It is actually 2 times 3 times 3 times 3. That gets us that, but let's see, if we multiply these together, that gets me 6. If we multiply these two together, that gets me 9. If I multiply 6 times 9, I get 54. If I subtract 6 from 9, I actually do get the 3 in the middle. So how do we get the x to the 4th? Well, x squared times x squared. What factors get 54 that subtract to get 3? 6 and 9. 1 carries the negative, and the 9 will carry the negative because it's bigger and the negative is in the middle. But now we still have more to do. We still have more to do. Putting this off to the side now. This still factors more because a perfect square creates it, and a perfect square creates this, and it has a negative in the middle. So how does that factor? Well, let's see. That means we're going to have x plus 3 times x minus 3 times the x squared plus 6. Okay, we're going to go to the next page and finish this. Okay, so right now we have x plus 3, x minus 3, and we have x squared plus 6. Again, we're trying to find x-intercepts here, so that means x plus 3 will be equal to 0, x minus 3 will equal to 0, and x plus 6 would equal to 0. Okay. When I solve this, I get x equals to negative 3. I get x equals to positive 3. But now something happens on this third one. We're getting x squared equals to negative 6. Let's think about that. Does that make sense? If we're going to square something, are we going to get a negative value? The answer is no. So we're not getting anything out of that one. So then the x-intercepts we get represented as a point would be described as negative 3, 0, comma 3, 0. Now we still need to take the same equation and let's find the y-intercepts that go with it. Again, by definition, that means we're looking for y value when x is equal to 0. Alright, well, let's take a look. This time we're going to substitute 0 in for x. So y is going to be equal to 0 to the 4th minus 3 times 0 squared minus 54. And let's work this out. Well, 0 to the 4th power is still 0. And negative 3 times 0 squared is 0 minus 54. Well, 0 minus 54 is then equal to y is just negative 54. But how do we represent that as a point? It would be 0, negative 54. Okay, so then these are my x-intercepts. If they ask me for specific ones, these are my x-intercepts. And if they ask me for specific ones, these are my y's. Okay. Alright. We found the intercepts. The next thing that they want us to do is test for symmetry. So what we could do to test for symmetry is actually plot these intercepts, and that kind of will help us out with the look of this problem. So let's go to the next page and do that. Okay, so our intercepts were negative 3, 0, 3, 0, and 0, negative 54. Okay, so if we were graphing this, let's take a look at what that would probably look like. And this is a crude drawing. We're just going to pretend that this is a negative 3 here. We're going to pretend that this is a positive 3 here. And do some pretending with me here. This is going to be a negative 54. Okay, so if we were plotting where these points are at, and you can actually put this in your calculator too, it would show you this right here. Now remember, it said that we weren't crossing the x-axis anymore. These are the only two places, so that means this is going down this way to finish this. This is going back down this way. It's not going to continue to go above the x-axis anymore. So let's look at this picture now, and let's talk about symmetry. If we're asking about the x-axis, look at the x-axis. Is there a mirror? Is the x-axis a mirror? Is the same things that are happening below the x-axis happening above? The answer is no. There's no mirror on the x-axis. What about the y-axis? Well, look at the y-axis. Everything that's happening on the left side of the y-axis appears to be happening on the right. So then, yes, the y-axis appears to be a mirror. Alright, so then the last thing they're going to ask about is the origin then. Well, with the origin, since both x and y were not, and the answer is no. Okay, so there's a rule that goes with this. The rule for origin symmetry says that it would have both x and y axes symmetry, or neither. X or y axes symmetry. Okay, and this concludes our notes for today. Hopefully this will help you with your 2.1 homework assignment.